Warm greetings. This is Mrs. Johncy Carolyn, Assistant Professor, Department of Chemistry, Nirmala College for Women. In this video, we'll see about nanomaterials.
Definition, its classification, types of nanomaterials, approaches followed in synthesizing the nanomaterial, and the application of nanomaterials. Coming to the definition of nanomaterials, these are unique, that is 1 to 100 nanometers. It is dwarf, that is nano means dwarf, the Greek word nanos, and it was discovered first by Richard Feynman in 1959, who laid the foundation step of nanotechnology, and he said there was a plenty of room at the bottom, and the term was given by Norio Tanguchi in 1974. The nanotechnology is the manipulation of matter with at least one dimension sized between 1 to 100 nanometers. A nanometer is a unit of a length in the nanometric system equal to 1 billionth of meter, that is 10 to the power minus 9. Coming to the classifications of nanomaterials. The nanomaterials are classified based on their dimensions, that is 0 dimension, 1 dimension, 2 dimension, 3 dimension. Dimension based on nanoscale. 0 dimension. All the dimensions are reduced to nanometer range, that is example quantum dots. 1 dimension, the materials in which one of their dimension is out of the nanoscale, that is nanowires, nanorods, nanotubes. 2 dimension, in which 2 of their dimensions are out of the nanoscale. Example, nanoplates, thin wires, planar quantum wells. Next one is 3 dimension, that is 3D, the materials in which 3 of their dimensions are out of the scale. Example, bulk nanomaterials, nanopowders. Coming to the types. The types of nanomaterials are quantum dots, wires, wells, quantum tubes, composites, and clusters. What are the quantum dots? A crystalline nanoparticle made of a semiconductor material that is small enough to show quantum mechanical properties is known as a quantum dot. The dimension range is from 1 to 100 nanometers. The electronic properties are intermediary of bulk semiconductor and discrete molecules. They are closely related to their shape and size. The size is inversely proportional to the band gap. Made from the range of materials that is zinc sulfide, lead sulfide, cadmium selenide, and indium phosphide. And it is toxic while using in the human body, therefore it is coated with a protective layer of polymer. This is a quantum dots. A very important thing in the nanotechnology is the synthesis of carbon nanotube. That is, it is tubular form of carbon, and it is diameter as small as 1 nanometer. Its length is few nanometer to microns. Configuration is similar to 2D graphene sheets rolled in a tube. There are 2 types of carbon nanotubes, that is single-walled carbon nanotube and multi-walled carbon nanotube, that is SWNT and MWNT. Single-walled nanotubes are made up of single rolled graphene layer, difficult to synthesize in pure form. It accumulates less in the body, hence used in biomedical application. And next one is multi-walled nanotubes. These are made of bunch of graphene layers rolled together. The bulk synthesis is very easy. It has high purity and it accumulates in the body more. That is carbon nanotubes. And the next one we can study about the nanowires. These are extremely thin. The thickness of diameter is equal to or lesser than 10 to the power minus 9 meter. The aspect ratio, that is length to width ratio, is equal to or greater than, that is 1000. And the applications of this nano wires are develops, that is in the development of microprocessors, prototype sensor and nano robots. The next one is nano fiber. It is produced from the variety of polymers like nylon, polystyrene, polyacrylonitrile and polycarbonate and water soluble polymers. The properties are very low density, large surface area to mass, high pore volume, small pore size, superior mechanical properties and possibility to incorporate the different additives. These are nano fibers. These are the types based on the arrangements. We have seen what is called quantum dots, quantum wires and quantum well. It is formed when a thin layer of narrow gap semiconductor materials lies in between a thicker layer of wider gap material. The size of the quantum well are generally between 1 to 20 nanometers. Next one is fullerene, that is we call it as a magic ball. That is, a fullerene is any molecule composed of entirely of carbon in the form of hollow sphere, ellipsoid or a tube. Coming to the approaches, how we synthesize the nanoparticles. There are different types of approaches. There are two types. One is top-down approach. The next one is bottom-up approach. First we'll see what is top-down approach. In this approach, the nanoscale devices are created by using larger externally controlled devices to direct their assembly. The top-down approaches often uses the traditional workshop or microfabrication methods, in which externally controlled tools are used to cut, mill and shape materials into their desired shape and order. The altering and milling for making nanoparticles are typical in this process. This is top-down approach. The next one is the bottom-up approach. In the bottom-up approach, molecular components arrange themselves into more complex assemblies, that is atom by atom, maybe by molecule, cluster by cluster from the bottom. From the smaller thing it starts growing, that is for example growth of the crystal. And the molecular component arranged themselves into some useful conformation using the concept of molecular self-assembly. For example, we can say the synthesis of nanoparticles by colloidal dispersion. Next, we will see about the applications of nanomaterials. What are the different applications of nanomaterials? First, we will see about the biomedical, and next electronics, consumer groups, agriculture and food processing. In nanobiosystems, the medical and health applications are, it enhances biological imaging for medical diagnostics, that is quantum dots are used. Early diagnosis of many diseases or the build of plague in arteries can be detected by using nanomaterial. Detection of early stage Alzheimer's disease can be done by gold nanoparticle. It detects a rare molecular signal associated with malignancy, and there are multifunctional therapeutics which is done by using the nanomaterials. And coming to the electronics and information technology applications in the nanomaterials are nanoscale transistors, magnetic random access memory, that is MRAM, enabled by nanometer scale magnetic tunnel junctions. The displays for electronic items incorporate nanostructured polymer films known as we use in OLEDs, that is organic light emitting diodes. And next one is flash memory chips. We are using it in the iPod nanos and the ultra responsive hearing aids. These are the electronic applications of nanomaterials. Coming to the agricultural applications, nanotechnology enables delivery of agricultural chemicals, that is fertilizers, herbicides, pesticides, plant growth regulators, etc. Field sensing systems to monitor the environmental stress and crop conditions can also be done by using nanomaterials. Nanotechnology enables the study of plant disease mechanisms. It is used in improving the plant traits against environmental stress and diseases. These are the applications in agriculture. Coming to the application in the antimicrobial, antibacterial coatings in mouse, keypad and cell phone castings, these are the very important application of nanomaterials. And sustainable energy applications are also there, that is in the goods. Prototype solar panels can be done, improved efficacy of fuel production and consumption, nano bioengineering of enzymes, it is used in batteries, and conversion of waste heat in computers, automobiles, home plants, power plants, etc. to unusable electrical power. These are the applications. And in the consumer goods also it plays a very important role, and in food processing also. And the other uses are 800 commercial products rely on nanoscale materials and the processes. This is a very promising application of nanomaterials. Above 800 consumable, that is commercial products, rely on nanoscale. The nanoscale additives used in polymer composite materials for baseball bats, tennis rackets, motorcycle helmets, and automobile bumpers, luggage, and power tool housings. And these are important applications of nanomaterials. And one more thing is that nano engineered materials found in food industry include nano encapsulation, nano composites, and in food containers we use in food processing also. Hope this presentation will be useful for you in knowing what is a nanotechnology, what is its definition, what are the types present, and what are the types based on the dimensions and the classifications, and the approaches, that is top down and bottom up. Coming to the applications in all biomedical, electronics, consumer goods, food processing and agriculture.
Thank you for watching. Hope you gained a clear knowledge about nanomaterials and their application.